quite tricky. It's a tricky name. Because the truth is, when you talk about least common multiple what? Right? Uh, Start with the word multiple. Okay, let's define terms first before we discuss. When you say multiple, and here we're talking about positive whole numbers only. Positive whole numbers. When you say multiple of a number, it's a multiple. I mean, this you should go back to the multiplication table. So, for example, what are the multiples of 2? Then you could recite so 2 times 1 equals 2, 2 times 2 equals 4. So it's, the multiples of 2 are 2, 4, 6, 8, 10, 12. What are the multiples of 3? 3, 6, 9, 12, 15, 18, 21, and so on. What are the multiples of 7? 7, 14, 21, 28, 35, 42, and so on. So those are multiples. And that's why and that's why it's important that you've mastered the multiplication table to be able to identify if a number is a multiple or not, right? Now we have term common multiple. What do you mean you say common multiple? Uh, for example, we have two numbers, right? Say, 6 and 8. Uh, Multiples of 6 are 6, 12, 18, 24, 30, 36, 42, 48, and so on. And multiples of 8 are 8, 16, 24, 32, 40, 48, 56, 64, 72, 80. What are numbers that are both multiples of 6 and 8? So, 6, let's start with 6, 6, 12, na, 18, na, 24, yes, 24, so on and so on. So, multiples of 6 and 8 are 24. I think 48 would be also. So yun, these are common multiples, right? But we talk about least common multiple. Among the common multiples, which one is the smallest number? And of course, the smallest number is 24, right? So that's how we find, I mean, conceptually, this is a concept, right? The meaning of the word least common multiple. Because finding LCM could also find LCM of not only two numbers but three or more. But that would be very complicated, so it's three. Now, doing this, especially, it's actually the doing this technique of, writing down the multiples, finding the least common multiple, is actually, um, it's it's time consuming, especially if you have a number or numbers which are quite big. So another technique of finding the LCM is this one. I don't know what's the name of this. I would say ladder technique. I learned this when I was reviewing for board exam. So, for example, when go back to the first example, 6 and 8, we know that 6 and 8. So, the first thing you have to do is just, write it down. It's actually, this thing involves division and factors. Factors are numbers that can divide. For example, when you say number is a factor of another number, if you can divide that number. So 6 and 8. So 6 and 8, you write it down. So start with that. And then you think of a number that can divide both. And obviously, they're both divisible by 2. It's very obvious there are. So 2 here, that's the divisor. And then you divide 6 and 8 by 2. So 6 divided by 2 is 3. And then 8 divided by 2 is 4. Now, think of another number. Could divide 3 and 4. Of course, there's no other number because 3 is prime number. And so there's no other common divisor with 3 and 4. And so we stop. And this is how we find the least common multiple. We multiply the number first divisor 2 and times 3 times 4. And the answer is 24. And so again, you try that with another example, and then you try that with 3 examples. And using 3 examples is quite complicated also because, for example, you have 6, 12, and 15. How about that? 6, 12, and I don't know, 6, 8, and 15. Here, the thing about finding the least common multiple when you have 3 or more numbers is as long as you can find a pair, meaning two numbers that has common, divisor, we still have to perform this division uh, thingy. So here's how we do it: 6, 8, and 15. So obviously, 6 and 8 are divisible by 2, but 15 is not. So this is how we do it. Okay, again, 2, so 3, 4, but 15 is not, cannot be divided, so just copy it. Copy. And then, so we have 3, 4, and 15. Or can we still divide? Can we still find two numbers that can divisible? Has two numbers have the same or the has common divisor? And can, because 3 and 15 are both divisible by 3. So 3 divided by 3 is 1. 4 is not, so we just copy it. And then 15 divided by 3 is 5. So 2 times 3, 1. There's is 6 times 1, and then times 4, 24, times 5 is 120. And so the least common multiple of 6, 8, and 15 is 120. Ooh. And what do you mean we talk about least common denominator? Should we talk about least common denominator? This is actually, so we talk about fractions, right? Because you talk about denominator, you're talking about fraction, right? The denominator is the number below. And so basically the least common denominator is actually the least common multiple of the denominators of a set of fractions. For example, usually you have to find the least common denominator when you're adding or subtracting fractions, usually. So basically we do the same techniques or same concept as LCM. Kaya nga lang, yung the numbers that you're going to find the least common multiple of are denominators. So basically, first algorithm or first step is to find what are the denominators of these fractions. So look at them, these, and kind of have to isolate them, especially, and then find the least common multiple of the denominators, and you have the least common denominators. The least common denominator is actually the least common multiple of the denominators of a set of fractions. Now if the two main numbers, looking back, this is just an additional thing. If two numbers are relatively prime, that's big. When you say relatively prime, they do not have any other common factor aside from 1. So like 3 and 5, right? Obviously. Then the least common multiple of these two numbers, or least common denominator, if it's common multiple, would just be the product, 3 and 5. So the least common multiple of 3 and 5 is 15. And for example, about 7 and 9, obviously. So 7 is prime, 9 is not, but 3, that its factors, 9 is not prime, but its factors are actually just 3 and 3 and 1. So its factors are 1, 3, 3, and 9. 1, 3, and 9. And so they do not have any common factor aside from 1. And so they are relatively prime. And so the least common multiple of 7 and 9 is just 63, the product. Now, if you have 6 and 8, obviously you cannot apply that rule because 6 and 8 have a common factor, which is 2, and then you have to go back to the technique that we used.